Hey everyone, welcome to another First Impressions. Rob Beeler. So glad everyone could join. Yes, we are recording. I'm going to make this video available on Beeler.Tech after we are done. By all means, feel free to turn on your cameras, if only just so I can see your faces when I make jokes and know that those jokes landed. Not that I need your validation that I'm funny. I just like to see the faces when those jokes hit, and sometimes I have to repeat them until you find them funny. This is the third of our series of DoubleVerify, and the first one was all roadmap, discussing kind of the idea that with DoubleVerify buying Adjuster, what that meant, and it was more than just having a publisher offering, but some actual integration. So I thought that was a good place to start. Last week, a little bit got actually into seeing what the publisher suite and some of those particular tools will look like. So that was a great one. If you again, both of those videos are available on Beeler.Tech to just the publishers. So just by all means, come and give that a watch if you didn't get a chance to see those. And the third one, we are leaving to video, which I'm going to hand things over to Peter for him to introduce himself. But I'm going to say, Peter, DoubleVerify and video are not two things I necessarily equate. I think I know why. I did a little research on who you are, so we'll get to that. But Peter, do you want to introduce yourself and talk about what your role is?
Yeah, for sure. So starting from the start, I joined DoubleVerify about just over a year ago, like a year and a half ago, as part of the acquisition of a company called Zentric, which I co-founded back in 2010. We were kind of video advertising specialists. Like, we build video platforms for several of the major ad tech companies out there, including DoubleVerify, and we kind of wide labeled that for them. So a lot of the well-known companies and platforms you would have interfaced with actually came from Zentric technology in the back end. And then as part of that, I participated as much as I could within the kind of industry working groups like ID Tech Labs to help kind of co-author some of these specifications like VAST, Open Measurements, and some of the newer ones like Civic, like CATS, like, which you probably may have never heard of.
Yeah, those are new ones. Great, fantastic, yeah. Awesome.
So I've authored all of those, like co-authored them with a few other people. But that does give me kind of a bit of a good insight into kind of what's living on that front on like cutting edge, and then what's the reality in real life across many different companies. And then we were acquired, and now at DoubleVerify, I lead the video and publisher products. So I oversee both product and engineering for everything that's kind of related to video and everything that's related to publishers.
Very cool.
The short intro.
Very cool. No, and so there are a couple of things there. So first of all, one, this is a demo conversation, right? Again, not necessarily getting into the product, but talking through what that product set is. So I want to make sure people have that expectation. Two, you just alluded to knowing a lot about this, and so by all means, let's put Peter on warning. If you want to dive into some of those topics, then Peter has already assured me that he's willing and up for the challenge. What I'd recommend is we're going to let Peter kind of go through his flow with things. I got a couple other preamble things to say, but by all means, use the chat feature to alert me that you have a question, or there's a little hand raising thing that you could do. But also, just at that point, when you have a question, let's just turn on your mic and let's ask it, versus me having to translate everything. So yeah, so I mean, Peter, the fact that you're focused on video, and that is, again, it's an interesting thing to think of DoubleVerify as rolling out this product. So I'm sure we'll kind of circle back to that. But I think I'd probably echo that with most publishers, that video is an area that I need to monetize as much as possible. There is money there. I hate seeing my vast error reports. This is truth. I got the call today of like going like, so why don't we have an ad for every single video that we serve on the site? Those types of questions or whatever. And so that's something that you've been looking to solve. So would love for you
Great.
to kind of walk through that. And let me make sure you can take over the screen and talk through it. And again, everyone line up your questions. Let's put Peter through his paces.
All right. But based on introduction, that's totally right. Like you may not expect like, oh, why would DoubleVerify be working on this kind of video platform or the video technology that we want to include in our publisher offering? But it's exactly what you just described. Is video inventory is kind of the most valuable inventory, and we feel that if we take a step back, if we from the perspective of DoubleVerify want to add value to the publisher space, then we need to think about how can we help, like how can we leverage all the data we have, all the information we have about every single ad execution, how can we use that to drive yield forward? And that could be either by providing more visibility into viewability data or fraud data or like brand suitability data. But we also want to think about how do we leverage some of the kind of technology platforms that we've built, that we've been using in-house for several years now. Can we expose some of that technology to help solve some of these issues and proactively drive yield forward by taking real-time actions? That's kind of what this is about.
By the way,
So
I'm going to highlight one key point, which is you just heard DoubleVerify talking about an offering for publishers, right? And again, we started this whole series by talking about that was, DoubleVerify, and of course is still going to continue to work with its advertisers and the agencies and so forth. But there is this switch and this move toward a balanced solution that will also help publishers. And so I'm just going to point that out, Peter, like your language there is not traditionally what I think most people would have heard. And I think that's really interesting that you're kind of taking that approach.
Yeah, absolutely. And that was also the strategic driver behind, for example, the acquisition of Adjuster, right? We saw an amazing technology company and that are building awesome products that are adding value for publishers. And that's exactly what we want to do. So we've been given a lot of freedom internally to work very closely with the Adjuster teams and kind of build a publisher-driven part of our organization that really focuses on adding value. So just on product and engineering, there's 60 people in the organization working on specifically for publishers, which is pretty amazing for a company that is originally very advertiser driven. So yeah, we want to invest heavily into this. And the key focus area for this talk, because there's so much stuff to talk about, but I'll kind of dive deeper into the video aspect of things, kind of what we're seeing happening, what we want to do about it, and then diving into a bit of the nitty gritty details, showcase some examples, and hopefully that can kind of help demonstrate of what we're thinking about doing here. So I would say the starting point is that building a broad video platform and kind of observing, like I think by now over like a few 100 billion impressions, vast impressions across the board, across the whole world basically, has given us some interesting perspectives into what is happening that is causing not all of your video inventory to actually give you a video impression. If we break it down, and this is just kind of one data set that we look at, we can break all of that traffic, all those video ad inventory analytics down by what happened in that inventory. So it could either be a success, meaning like a billable event, like an impression, could be that there's an error, vast error that came back with all sorts of error codes. That's the Google Ad Manager report we were talking about, which is wonderful to look at. And then finally, there's this category, like I think Google demonstrates is like you have the ad served count, which is like always very much higher than the impressions plus the errors for some reason. So the delta between all the ads served minus the impressions minus the errors, like what happened to those? That is a massive category in its own, which is like what we call unacknowledged, which is no data point came back from the client side. So it's kind of evaporated into thin air and there's no real clarity on what happened on the client side about it. And if we dive deeper into the segment of errors, like what we see is that kind of the majority of the errors relate in some way, shape, or form to timeouts. So this is a bucket of all sorts of different error codes, like 301s, there's 402s, there's like a number of different error codes that all kind of refer back to timeouts. And then even if we look at a whole bunch of the VPID errors, like the 901 error codes, if you dive deeper into what triggered the VPate to throw an error back at the player, it will actually be a timeout as well. So we bucketed that all together into a single category. And then the second biggest is no ad, simply someone like making a programmatic bid or giving you a VAS tag that eventually returned an empty ad response. So although everybody was thinking there was going to be an ad, it ended up being nothing, nothing to render. So that's also a big contributor. And so before we continue, I wanted to kind of dive deeper into like the anatomy of what a video ad looks like. So everybody here's like this VAS, and if you've opened one of these tags up at some point in your life, you'll see that it's kind of this gibberish of XML, which basically is a metadata description, right? It's like giving you information about what's the duration of the ad, what's the resolution of the media files, and you'll generally maybe have a few of these media files available so that the video player can pick one with the right resolution, the right bit rate, with a video format that it actually supports. So you'll maybe have like 10 of these media files showing up. And then it will be a whole bunch of tracking pixels, like impressions, errors, quartile data, completion, all that kind of stuff.
Okay.
So that's a quick overview, but then that's the ideal case, is that it's as simple as this. Obviously, nothing in AdTech is as simple as this. So that's when kind of the wrappers come into play. It's this idea that I can serve a VAS tag that then actually redirects to another VAS tag, which then redirects to another VAS tag, which redirects to another VAS tag. And you start building like this whole mess of network requests pointing to each other and doing a bunch of bad stuff. So what the result is that I kind of end up in a situation where I have the video player making a first request, which is kind of the, I like to think about it like an onion, like the outer layer of the onion, which is the outer wrapper, and then you have a next wrapper, and then the next wrapper until you get to the core, which is actually the video file that you want. And I, as a video player, need to now make 4 network calls in sequence to get to the final asset that I'm interested in. So obviously not a great experience, but this is how almost all of the intermediaries in the industry are injecting their tracking pixels. They're starting off from, for example, the video tag coming from the buy-side ad server, and then I add an onion layer around it with a wrapper that inserts my tracking pixels, like as the DSP or something. Then you have an SSP adding some tracking pixels with their own wrapper around that, and then you add someone else with their own wrapper around it, injecting even more tracking pixels. It's kind of, yep.
Yes, that's interesting, right? So in display, what you typically are seeing is on the agency side, they are adding and appending these tracking codes, but that's just adding into HTML, another JavaScript thing, and they just get added.
Yep.
I'm assuming the complexity and so forth with video and such is that it's like, well, you know, instead of us trying to inject something, we'll just wrap it again.
Yep.
And again, it's a Russian doll style / onion approach of just adding all of these layers onto it. Got it.
Exactly. So instead of like appending some HTML to a display creative, you're like having wrappers pointing to wrappers pointing to wrappers pointing to an inline, which is kind of originally how VAST was designed back in the old days. Like I think the original version was like 2009 or something, or 2008 even. But yeah, this is kind of what we have as legacy now. And there are better ways of doing this, but just like everything else, nobody ever upgrades anything. So the whole industry, even though we're at like VAST 4.2 right now, 99% of all the traffic is still VAST 2.0. So, and that's kind of, we'll take some responsibility in behalf of the tech lab here. It's what we do is every important new feature that we introduce in VAST 4.x, we provide like a backport to VAST 2.0 as an extension node. For example, open measurement was like going to be the killer feature for everyone to upgrade to VAST 4. And then we said, oh, by the way, we're going to add this extension node to VAST 2. So you could also do open measurement in VAST 2. And then like we killed the killer feature and everybody stuck to VAST 2 with the extension nodes. So yeah,
well, if time
shot ourselves in the foot there.
If time permits, we should talk about that, right? We should talk about, again, so not only your product, which helps with this, but just like some of the other best practices around that, if time permits,
Yep.
you know.
Yeah, for sure.
Because it sounds like you're really involved in that stuff.
So I just wanted to kind of quickly demonstrate. So I just set up some example tags here, like a wrapper, which points to another wrapper, which points to a video VAST, which is on this video file, like Big Bugs Bunny. And then I loaded it in our testing tool, and just to kind of show you how this all plays out in reality. So when I load this thing, what you see in the network traces is you'll see a request to wrapper 2 from the video player, which will then be pointing to wrapper.xml, which will be pointing to video.xml, which will be pointing to the video file. And each of these, of course, takes time, takes latency. So you kind of see it all adding up into a pretty significant time sink. End result being that, like, if you look at when the actual impression fired, let's see where it is here in the log. So impression, if I go over this thing, it should give me some tooltip with some data, I think. So it took 785 milliseconds in this run. And I'm on like an actual cable connection, right? So I'm not even a Wi-Fi, or I'm not even a 4G. All of these network requests on a fast actual network cable connection ended up in like 800 milliseconds of load time before I could fire an impression pixel. And that would be potentially an order of magnitude worse if I'm on a slower dial-up connection, like, well, dial-up obviously, but 3G, which is practically dial-up in these days. So that's kind of what I'm talking about. So let's take a look. What do we do about that? So the kind of thing that we are that we've been doing already on the buy side for our customers, but that's kind of all the way at the end behind the DSP on behalf of like what we've been doing as DoubleVerify is we want to also inject our own tracking data. Obviously, we want to inject viewability measurement. We want to like do fraud detection, all the magic stuff that we do. So we, for the last couple of years, have been doing exactly the same thing. We've been injecting all this tracking data. The challenge was that we kind of had a whole bunch of, before the OMID world, we had to use VPay to do viewability tracking. And VPay wrappers are even worse than what I just described because they add like wrapper, vast wrapper, vast wrapper, vast inline, VPay JavaScript, which then triggers a new vast request, which then triggers a new media file. Like it's kind of even more complex than this. So what we had built is internally that we've been deploying for 3 years now is an accelerator system, which is if our server gets a request, rather than sending back a wrapper response, we do all the requests behind us on the server on behalf of the client. So the video player would make a request to our service. We would generate wrapper 2, which is our data, which would point to wrapper 1, but we make that a server-side call. We grab that response. Then we follow the next stage. We follow the wrapper server-side again. We get to the inline. Oh, sorry. We get to the inline. And now we take this whole chain on the server and we squash it together into a single payload back to the client. So the video player, eventually, the only thing they get to see is an inline response. They never get to see the wrappers because they're resolved server-side and squashed together into a single payload back to the client. And that means that rather than having to make these 3 calls client-side on a slow mobile connection, I can do these from a data center in a server, which speeds up the process quite significantly. So I can actually show what that looks like. So I had the wrapper pointing to a wrapper pointing to a video file. If this thing can just move, yep. Which gave this result. So this is what happens when I route the exact same chain through the DV accelerator. So while I'm pointing to the wrapper node, when I make this request, the accelerator actually returns an inline with all the data squashed together, and then we inject some of our own trackers on the way because we want to track the results, like how successful was this? Did it fire an error? Did it fire an impression? To give you some analytics data for the servers as well. But in the end, it's just basically the whole vast chain squashed together. And if you run this, if you look at the network trace again, what you get to see is there is a single vast request. This one to the to video.doubleverify.com, which immediately returned the video file, which starts playing back. So there's only one vast request on the whole page rather than what would have been 3 originally. So that's basically the core of the acceleration process is move work from the client to the server where you can do it very effectively. And in a way you can imagine, it's kind of the same concept as when you think about Prebit.js, where they introduced Prebit server to offload some of the work from the client to a Prebit server, because there you can make many more requests without actually impacting performance. It's the exact same concept, basically. Move all these requests server side.
So it's, yeah, and I think that's pretty clear. I'll say it in my own dumb way, if you will, right? So it's like, again, this is all live. This isn't caching anything. All that it is doing is it's taking the existing creative, which has all this stuff, and instead of pushing it onto the browser for it to do the work, I'm going to do that on the server side,
Yep.
do that work, get everything all together, which was the end result of what would have been delivered to the browser, and just
Yep.
deliver that to the browser. So all that work,
Exactly.
and then add the tracking into it. So again, you add some additional spots onto it, so you know what might have failed if there's
Yep.
any kind of failure that happens.
It's exactly that, and that kind of what we've seen is that obviously the obvious effect is reducing latency, but reducing latency means reducing timeouts,
Right.
and reducing timeouts means better user experiences, improved monetization, more actually delivered impressions, kind of all the nice side benefits that you get on top of that.
And
So,
if
but
anyone has
this
any
is the core.
questions about what you're seeing, if anyone has any questions about what you're seeing, by all means, raise your hand or speak up. I got it, so I'm assuming everyone else got it. Right? That's
Yeah.
typically my approach on this, but it does make sense that this is why you're accelerating it. You're just you're just making that stuff onto a much faster system than the browser. That's the last place we want to put even more weight, right? It's already, the connections and everything else. Got it. Okay, keep moving.
So second piece is that what you'll notice is like you'll see this kind of unique code here, and it says EWR, Newark, which is the data center that serviced this request. The way we're running this whole system is it's globally distributed on over 200 data centers worldwide, which means that it's actually running on CDN infrastructure, all of the logic for this thing, which means that we always have a data center very close to the user. While these ad servers there may be one on the West Coast, one on the East Coast, one in Europe, there may be a handful of ad servers for a particular vendor. By having like a CDN in front of it, we also accelerate the process of actually making these calls. And while none of the requests is actually cached, there's a whole bunch of optimizations we can do on the CDN edge, just like you would do for any of the static assets on your website. We can leverage CDN technology to accelerate all of these network calls as well and make them faster. So that's an additional layer of optimization living kind of on top of the logical process of condensing the vast response.
Now, I will say, Peter, that if you're using Newark as an example of a hub where things are faster because you have, I'm going to just say that that's probably not your best example, because of course I'm thinking the airport. Just maybe not. You might just want to run that through a different one for the next time you demo it. I'm just going to put that.
Fair enough. I'll just have to move to Miami and then run it.
Yes, exactly. Well, if we can literally do that. So, rerouting, right? I mean, this is traffic. You did mention kind of edge computing, which I think, that's the one thing that I'm hearing a lot of, and I think is really interesting technology for everyone to start to kind of look into, especially if you're the ones that are doing the edge computing, right? Because I think not every IT person is in favor of doing stuff at that level, but if you're the one that's doing it, essentially you're doing a lot of stuff about as fast as you can possibly do it on the internet at that level, and cutting through a lot of the noise. Right?
Yeah. And I would say the benefit from our perspective in using edge compute for this use case is that it's like a perfect fit for this. So edge compute is basically this concept of, rather than like having 3 regions, 3 data centers that on Google Cloud or Amazon or something, I'm going to take my code, I'm going to have it massively distributed in like these 200 data centers globally. And that means that I can just deal with any level of scale that you throw at it. We had like whole ad networks activate their traffic on our accelerator as we were testing this out. And it would just infinitely scale. Like we would be able to handle millions of requests in just the blink of an eye. So that kind of infinite scale, infinite response times, and super close to the end user gets you all the benefits of what you expect from a CDN.
Very cool.
So if you experienced 800 milliseconds, would you expect that to be cut in half? Would you expect that to be cut by 25%, by a third? Would we get down to 100 milliseconds?
Yeah, absolutely. So I would say across several deployments that we've seen that we can get to like 30% reductions in fast latency on these chains. There's a little bit of, so for example, we've seen better results in Australia than in the US, simply because Australia is so far away from all these ad servers. The optimization is obviously a lot better as well. The closer you are to the ad server, the smaller the improvement you would see. But so geographic markets are great. If you have a lot of mobile traffic, that is a great optimization because they have a lot of latency as well on the mobile connections. So it kind of varies a little, but that's kind of benchmark what we like to see, and that's measured from the actual video player on the client side. So that's not like measured server side or something. That's actual data from our customers on their video players on the client side.
Okay, so if you can achieve a 30% reduction in latency, do you have a sense of what that models out or what that translates to as far as timeout errors? Is it a 30% reduction in timeout errors, or is it a, say, 60% reduction in timeout errors?
Great question.
Yeah. So in the subset of timeout errors, like overall, we've seen errors reduced by 30% as well in these cases. But if you look at specifically timeout errors, like they evaporate basically. Like for example, if you look at 301 errors, like VAST timeouts, I was just looking at some data from a customer this morning. They basically saw that from like a substantial percentage of their errors in their VAST error codes basically reduced to near zero. So it's at that level, it's a massive improvement in terms of reduction errors. And then of course the holy grail is, sure, you reduce errors, but does it automatically mean more impressions as well? Which is kind of the final goal of what you're trying to get to. Then yes, that too. Like I would say the best case scenario that we've seen is we've had a customer see their impression rates, like the number of impressions on their inventory, increase by 45%, which I will grant is the extreme case. Like I've not seen any other customers do that, but that's kind of the higher barrier of what we've achieved. And I would say on the lower barriers, we've seen improvements like on the lower end from 3 to 5%, which is much more, it's a much smaller benefit, but it's somewhere between that range, you know, and it kind of then depends on what your distribution of traffic looks like. And we are continuously improving that. Obviously, we're trying to, that lower bound, that's what we're trying to get up, so everybody can get at least a 10% improvements. That's kind of the objective.
You got to appreciate that Peter's not the sales guy who just sat there and just held on that 45% number. You did kind of give the engineer answer of like 3 to 5%, which again, you sit there like, okay, that's something, right? But I think that that's a part of like where you're going with this in terms of seeing it, working it, and so forth. And it's the results will vary. But I think
that's what I always say to customers in this stage, with the early stage, like we are just deploying this with customers for the last 6 months for the first set of times, and beyond what we've been using internally for the like earlier 3 years, is that yes, we're going to stabilize this, but I want to be fully transparent. Like for some people, it's amazing. It provides massive benefits, like tens of thousands of dollars of additional monetization every month for some people. For other people, it's 3 to 5% improvement, which is still nice. Like I still want to see my revenue increase with 5%, you know, but it's not like world-shocking improvements like that.
Okay, keep moving, sir, because I'm curious, and again, I know you've got maybe some other concepts here to hit, but I'm curious about implementation and all that kind of stuff. So by all means, keep. All right.
What is this? Yeah. So kind of what I wanted to talk briefly about is this idea that it's not only the acceleration. Because we move all the work server side, it means we can do a huge amount of logging and tracing on the server as well about every single step that we follow on that server. So we can log all the different ad servers that we hit, how fast each of them responded, how much each of them correlate back with errors, and we can start building a much wider picture of what the hell is going on, you know? Like rather than just pull the GAM report that says I had so many errors for these campaigns, let's say I have one of these is an SSP or something. They may be sending me 15,000 different things all day long, and I kind of want to map out what that flow looks like. And I just want to kind of visualize that we do have all of that data. We can actually trace down all of those vast paths along all of your, like every single impression, and kind of figure out where it's getting hit. And then we can figure out which segments of that traffic then ended up in failures on a per impression basis.
Interesting.
So
okay. Yeah.
Helps visualize the supply path, helps kind of figure out on a per hop basis rather than measuring end to end which parties are introducing the latency, figuring out where the errors are coming from. Also fill rate, like if you get a ton of 303 errors, which is empty VAST responses basically, this can trace it down to an individual party that is generating it for them. So we already helped some of our customers identify, hey, actually after 2 hops, it actually ends up with a particular platform that is then sending 99% 303 errors because they have no fill actually. So you can start doing optimization based on this kind of mapping. And then finally, we see huge correlations between what are the media files you're getting back from these ad servers along the way. If that's VPaid, are those regular video files? Is it a combination of both? And that has a big correlation with the error rates as well. Like obviously, if you're seeing like people sending back like 90% VPaid, then you have massively higher error rates than if you just see raw video files in the responses.
I mean, you're getting server level data about all aspects of these transactions versus a JavaScript sending back a tracker saying this is what happened, which can get affected as well. So wow, that's a lot more information. Yeah,
exactly. So and I would say we're starting to visualize this data in better and better ways, like the graphs that I'm showing right now. We are kind of iterating on all these dashboards. Like we have 50 different dashboards internally to track all this stuff, and we're trying to figure out what is the best way to externalize this back to our customers. Like, how do we help you understand what's going on without throwing raw log level data in your face and expecting you to make sense of it, you know? But that's kind of what we're working on right now.
So Rob, do you mind if I make a comment?
No, please.
So just on the concept of verification in general, you know, DoubleVerify and IIS in particular, you know, it started out, and maybe you guys covered a little bit of this in the other sessions, but it started out as this war where, you know, the media buyer wanted to verify where it was running. And as, you know, publishers have worked with DoubleVerify and IIS and these other providers, one thing I felt that was missing a little bit was the other side of that coin is, hey, we noticed that your IVT has been spiking or has been, you know, above normal. Hey, here's your alert on that. You didn't have to set up the alert. I've got all your data. I sent it to you. And by the way, here's a lockbox with the log level file so you can figure out what the heck's going on. But so just when I saw this slide is if you can, you know, do that path optimization and then without me having to set up alerts or ask for it, you know, sort of say, hey, here's what we're seeing is that SpotX is all of a sudden sending you VPaid. They weren't sending you VPaid yesterday. You might want to check it out. That's very interesting to me. That's where the two sides of the coin, the publisher and the buyers, are working together to optimize the supply side, whether this kind of crap is, you know, hey, it's your fault. No, it's not my fault. It's your fault, you know, for what it's
worth. Absolutely. And then we did cover that briefly in, I think, one of the earlier sessions, but the goal is indeed, we're going to provide impression level transparency, not only on like, we flag this as fraud, but also telling you exactly why we flagged it as fraud. Did we think it was data center traffic? Did we think it was like, we have like a whole bunch of categories of why something may be flagged as fraud, and we want to provide you with full transparency into every single impression to not only tell you yes or no, but also why. And we do the same for viewability, we do the same for fraud, and we're basically providing impression level brand suitability transparency too, like telling you exactly for this impression on this exact URL, this is exactly all of the categories, the categories that we associate with that page that influence the decision process. So you can clearly see on a per article level, on a per page level, exactly how we classified that. And that data is available to you in real time upfront, so you can use it in key value targeting in GAM or something, if you want to target towards or away certain stuff like that. But it's also available like as post reporting in dashboarding and that kind of stuff. So yeah, it's a pretty rich data set.
I can't speak highly enough about last week's session in terms of doing it. Like again, the idea of watching an old demo can be a little bit tough. That one's worth it in terms of that dive into that and so forth. So yeah. So Peter, keep moving.
Yeah, sure. Now I explained like, great, we can optimize fast, but the reality is like a lot of our customers are seeing like 80% VPaid traffic, you know, like massive amounts of VPaid still, although everybody's trying to get away from it, the reality is it's still pretty much out there. And then the reality is that a lot of these VPates are actually wrappers themselves that then hide a VAST chain behind them. So it's like a moat wrapper who will then fire a new VAST request behind it. And obviously, like, if we're scanning through with the server and we hit that VPate, we actually have to run the VPate client side in order to know what it's going to do before we kind of can figure out what the VAST chain is that is living behind it. So this is kind of generally where this acceleration process would hit a brick wall. It would be able to do the whole VAST chain before the VPate, and then behind the VPate, it would kind of not have the power to run that. So the question is, what can we do about that? And the way, like, this is actually, we have a patent pending on this thing, but the idea is that what we've built this technology that can kind of detect what the URL is that's sitting behind the VPate wrapper and already kind of predict that server side. And then what we do is we accelerate the first VAST chain, we hit a VPate brick wall, we send the VPate back, but we instruct the VPate so when it starts running, rather than go through the normal process and fetch the VAST chain behind it, that it goes to the accelerator again to get the next set of VAST behind it. So that we re-accelerate basically the process behind the JavaScript. To the point even where in the first run of the accelerator on the left here, we will already start prefetching the second chain as we're sending back the VPate, so that by the time the VPate starts spinning up on the client and starts calling out for that second chain, that we already have it preloaded in the server ready to go. So that's saving quite a bit of time as well. Right now, this is kind of rolling out on a percentage of our traffic, so we're still evaluating to make sure it's super safe and that there's nothing breaking. So far as everything is looking good, and we see nice kind of improvements, like 7 to 10% improvements in speed if we apply this technology as well. So that's very promising and something we're working on. Then finally, I want to kind of provide another perspective is, so we talked about 2 acceleration methodologies. This is basically a third. And for that, we need to kind of dive deeper into what it actually takes to make a network call from the browser. Basically, there's multiple stages in the process, and you can see this in Chrome. Like if you open the network activity tab and you click on one of the requests, this is kind of the timing tab you'll get to see. And the process is like, first your computer needs to make a DNS lookup, like translate VAST to DoubleVerify.com into an IP address. Then it establishes a network connection, TCP connection, with that IP address, which is the orangey bar here. And then once it has a connection established, it needs to do an SSL handshake, like do TLS SSL is the same thing basically. That takes 2 round trips. So I need to make a call, wait for the response, make another call, wait for the response. And then finally, once all that work is done, I can make the HTTP request. I can request a specific URL and get the response back. So in total, if you sum it all up, I need 5 round trips on the network to get a single HTTP request. And obviously, that's a huge amount of time. If I'm on a device with a ping of like 40, 50 to 400, 500 milliseconds, each of those is taking 500 milliseconds going back and forth. So after 5, I'm at 2.5 seconds to make a single request, which is massive. And that kind of compounds if you have a sequence of requests. I have a VAST pointing to a VPate, pointing to a VAST, pointing to a video. That all just kind of starts stacking up. And if each one of these takes 2 seconds to load, yeah, you're at like 8 seconds load time for not too complex VAST chain. So what we're optimizing is our server actually, even if it hits a brick wall for VPate, it will predict the requests that it think are likely to happen behind the VPate, and it will provide browser hints back as part of the first VAST call. Like let's say the first VAST call is to DV Accelerator. It will provide hints back to the browser saying, hey, I'm predicting you're going to need a network connection to this and this and this and this endpoint. You should already start building those connections ahead of time, so that by the time the VPate starts running and starts telling you it needs something from you, you already have a connection ready to go. And that moves all of the work that would normally happen here at the later stages. Like I use the same color coding, DNS, TCP, TLS, and then the network calls, the actual HTTP requests. It moves that work up front and parallelizes it, so it doesn't become a serial thing, but a parallel thing. And that is kind of taking a whole chunk of the work as well and making sure it's more efficient. I can kind of briefly show that too. When we look here at this accelerated response, what you'll notice is this thing in the response headers. So you see link, then a certain domain, fast latency, blah, blah, blah. This is part of, this is where my video file is hosted basically. And it says pre-connected this domain. So the browser will already start establishing a network connection to that domain, anticipating that it's gonna need to make a call to it. Same for, we add one as well for our tracking pixels so that all this latency is less relevant for the tracking pixels, but even those will be faster simply because we've pre-connected to the domain where our tracking pixels are hosted. So that's a very cool technique that we use extensively to, as an additional layer of optimization on top of this.
Interesting.
All right. Then this is kind of what we already talked about it briefly. It's like, what are we getting as results? Latency reductions, error reductions, impression increases. All of those are kind of what we care about. Obviously, impression, that maps directly to revenue, but then latency maps to better user experiences. So even those can help like with stickiness or with people actually watching multiple videos in sequence rather than immediately leaving after the first because it's a horrible like loading experience for ads. And even latency, viewability. So what we've seen is that with every second of load time, you lose about 8.5 percentage points of viewability rate. Because simply people leave, they close tabs, they scroll down on the page. So reducing latency not only boosts impressions, it also increases the viewability of those impressions as like an additional dimension of monetization improvement. Obviously that increases the value of the inventory as well. So that's kind of a nice benefit too. And then of course the indirect benefit is having this whole analytics stack behind it allows you to do manual optimization even on top of what you're getting from the automated solution. And I added the asterisk below. Your mileage may vary. As I said before, we do see ranges of results. So I'm not gonna say that everybody will see their impressions increase by 45%. But,
so what is so Peter, what's the implementation? What,
Yep.
Talk to us a little bit about what this actually looks like.
So it's actually pretty straightforward. So basically what we give you is we give you this URL and you just drop in with a macro or with something else, like you drop in the tag, the VAS tag that you want to have accelerated, and then it becomes a VAS tag in itself. So I can literally log into Google Ad Manager, set up a video campaign. I got a tag from my buyer. I can wrap it with this URL. I put that into GAM as a creative, and that's it. So it's super straightforward. In the same way, let's say I have a pre-BGS setup or something. I can just take the cache tags that they ask me to put in all the kind of line items. I can just wrap each of the cache lines, the VAS tags, with this thing and dump them into all those pre-BGS creatives. And that's it. That's all I have to do.
Okay, so I was going to say, like, so you can do this. You started with going campaign by campaign, but this is something that I can apply across the board.
Yep.
Because that's, again, I was sitting there trying in my head, sitting there going like, it's the ones I don't tag that are going to be the ones that are problems. So
Yeah.
that I have. But so again, so got it. So it's essentially putting this into your templates or your files, so that all your video are kind of running through this.
Mm-hmm.
And then you're building out probably user interface so I can kind of see those analytics piece of it.
Correct.
Right?
So that's what we're working on right now is the dashboarding, the analytics, like externalizing all the massive amount of data that we have in the most like usable way. That's what we're building right now. So we hope to have that in a couple of weeks to a couple of months. I'm an engineer, so I'm optimistic about these things. So.
Cool. I mean, and again, because I know this is kind of coming out to market. So
Yep.
have you established the pricing model? Is this built in with other, again, DoubleVerify is now creating this suite of things for publishers. Is it built into that, or how does that work?
Yeah. So we're defining that right now. I think we'll be announcing that in the next couple of weeks, what that will look like.
Okay.
The basic concept is that we're trying to make sure that we find a good balance between, obviously this thing does more work every time you send it a request. So the natural thing would be to charge a CPM fee or something. But we do want to kind of create some certainty around that, like the predictability, budgetability. So I think it will be a mix with like, where we say, for a fixed fee, you get X amount of volume. You can just throw whatever you want at it. And then if you really start going to large volumes, maybe there's a small incremental CPM fee on top of that. But the obvious intent is that because it measurably increases impressions, our objective is that we can show that it increases impressions by more. Like you're actually making more money than we cost you, right? So that's the obvious ROI calculation. So unlike many other solutions, this is actually something you can calculate ROI on, which is nice.
So first of all, this would be a really good time for people to raise their hand or to ask questions. With the fact that, and I'll just say that while people queue those up or think about those, so at this stage, is there anything a publisher should do other than kind of raise their hand to say, I'd like to be first, coast to first, or something along those lines in terms of, I mean, are you still beta testing, or are you at this point where it's time to wrap it up and then roll out sometime in August or September?
So we have a number of tests live at this time. Obviously, anyone interested, come and talk to us. We'll add you to the list of people that are already expressed interest. We'd love to work with you to figure this out, kind of test it out, see what the impact is. We're not currently expanding the beta simply because of the fact that we intend to launch it in the near future.
Right.
So it makes sense to just wait for the launch and then deploy it. But even then, we're very open to anyone that is willing to just give it a go, tell us what they see, and we can look at the data together.
I know some of you on this call are certainly in the broadcast. I mean, you live digital video, so it would be really good for you to ask questions without me necessarily trying to manufacture them as I'm about to, right? Which gets into the fact of like, so first of all, this is applies across all VAST vPaid versions. There's not a I need to be on VAST 4.0 to use this. It all the way up and
You'll
down.
see this is a VAST 2 tag right now. So
yeah, and then obviously on the broadcast side, there's work that's involved in. Well, so here I'll go first. Like, so Freewheel and Google Ad Manager. Is there any difference between those two? Is this just work with Google Ad Manager?
So the core is that this is VAST compliant. So anywhere where you can drop a VAST tag, you can drop this as well. I would say the only thing is that our UIs, like the dashboards, are going to have initially in the initial version a close integration with Google Ad Manager. So we can pull like, let's say you drop in a macro with like your line item ID or something, that we can look that up, what the actual readable name for that line item is by calling the GAM API and then showing that in our interface. So you don't have to work against like unreadable IDs, but you can actually work with titles. That's the only thing that's currently closely integrated with GAM. But it's not it's a better experience, but this VAST tag works just about everywhere.
Got it. So
I have a question.
Yeah, thank you, Rachel. Yep.
Sure. So how do you implement this on the publisher side? Is this something that has to be integrated into the app, or is it like a ad server where we have to drop the VAST tag into it to serve it? Like, how does this get incorporated to actually work?
So normally you would be able to just activate it from within your whatever you use, Google Ad Manager, for example. So you'd be able to go in as an ad ops person, and where you have a video campaign right now that is serving a video tag, you could just plug that video tag in here, get the new accelerated tag, and serve that from GAM as a third-party VAST creative.
Awesome, thanks.
But you did talk about, and you mentioned this with pre-bid, but this idea that you could implement it a little bit more of a macro or slash across. Again, I'm not using the right term.
Absolutely. So with pre-bid, you would have like a pre-bid creative setup, right? For video, which generally the pre-bid video creative will point to like this cache server, blanking on what the name is, but it's like a pre-bid video cache server that has a macro for some kind of unique ID that is sent from the client to the server that is going to be filled in as a macro. So you can just drop that same pre-bid cache URL. You can drop that in here too. Save that as your pre-bid video creative, and then all of your pre-bid traffic will automatically get accelerated.
Got it. So Rachel, there are ways to do the, because again, when I hear Peter say that, like, oh, you can go in with each video creative and do that. I'm not really wanting to do that,
yeah, for
right?
sure.
Like, so
Yeah.
the fact that you could create the templates or whatever so that it gets included,
Yep.
is there. Okay,
Mhm.
cool.
Yeah, I think in the future, what we want to do is provide some tooling as well. Like, for example, a browser plugin or something where if I'm in my GAM account, I can just like, or like a tool from our UI or something where we can allow you to click a button and it like upgrades all of your campaigns or something to acceleration or whatever, so that we can at least help automate some of the manual workflow.
Very cool. Very cool. Any other questions on the video product? All right. Well, first of all, Peter, thank you for that. Can you mind if you
You're
take
welcome.
off screen sharing just so we get the back to the picture on that?
For sure.
Cool. Thank you. So, really cool. Again, I think it's really interesting, this being the third, the trilogy, if you will, of the DoubleVerify series, right? Kind of starting off with why, DoubleVerify acquiring Adjuster. What did that mean? What you're seeing there is that these tools are getting integrated, right? And then again, that this is a product that, while
Recharge.
say that, but the idea that, like, obviously this is a tool that some of the buy side can use. This is really very publisher focused, right? And something that we can use. It's pretty exciting. So, Dan, Peter, anyone else on the DoubleVerify side? Any final thoughts as we kind of wrap up the trilogy here? Send Gandalf and everyone else over there. I'm trying to think which trilogy I want to join here. Go ahead, Dan.
I think it's worth mentioning, Peter. When we our existing clients, we start to move them over to this combined package. One of the first things you're going to be able to see as it affects the video acceleration is we're going to get insights to your video inventory right away, and we're going to be able to help you on a one-on-one basis. Give you insights on where your video traffic is having some trouble. And be able to have a really intelligent conversation with real data from the measurement that you're already getting to talk about, whether video acceleration is going to make sense for you.
Yeah.
Yeah, and you could immediately start like seeing how this all starts coming together when you think about the products that Adjuster has offered, right? Like Flow IQ, Programmatic IQ, the ability to tie all of these data sets together into a single reporting view to talk about revenue data, in the context of quality data, in the context of performance data, like the video data that we talked about just now. If you tie all of that together and you can join it at like a super granular level to kind of see how performance is impacting my viewability rate and how that's in turn impacting revenue, that becomes a very powerful story around tying all the data together.
Yeah. Well, I'll give just, I think, Dan, to your point, and Peter, to your point, right, is that, for me and my IT team to even add anything to our video player, to do anything that might add any level of latency, is just something that we're fearful of. But if I'm in a position where if I do add something, I can immediately see whether that's a really good partner for me or not. And again, as you kind of laid out, there's any number of variables in that, right? And so if I can sit there and say like, hey, it works for someone else, but doesn't work for me, as long as I know that, and then I can make those decisions on that, I can start to really work on the video side with some real information. So I think that's an exciting development to kind of work to. So,
yeah, and I think in general, what we see is that you generally lack the power to really hold people accountable, right? Like, even if you detect an issue, how do I force them to take action and actually resolve it on their end? Because they are in control over that. But if you have actionable data that shows like, hey, you're the culprit, like you're actually causing bad stuff to happen, that gives you much more ability to just kind of point to the data and say like, look, it's not me saying this, it's like the data's telling me this, so let's figure it out.
Right. Very cool. I'm going to